All right, good afternoon, everyone. My name is Isra Al-Bashir, and I am the Director of Art Museum and Galleries. Before we begin, I want to take a moment to thank those who made today's event possible. My deepest gratitude to the Terra Foundation for American Art for their generous $50,000 grant that helped actualize the exhibition Stephanie Shih, Long Time No See. You can see part of the body of work behind me here. I also want to extend my gratitude to our sponsors, the Physics and Engineering Department and the Asian American, and Pacific Islander W&L Employee Resource Group for their support. I'd also like to take a moment to extend my appreciation for my wonderful team for making this event successful. And to everyone here, both in person and virtually, thank you for sharing your evening with us. Tonight's event is uniquely tied to our current exhibition, Stephanie Shih, Long Time No See, a series of 15 photographs and video still life installations displayed across our galleries within the Reeves Museum of Ceramics that is on display through June 7th to 2025. So please visit, bring a friend or a family. She was our first and our 2023 inaugural artist in residence, during which she created a new body of still life photographs that drew from our nationally renowned collection of Chinese export porcelain. Since the opening of the exhibition, Long Time No See has provided us with fertile ground for profound discussions on art, history, and various ways to produce knowledge. The exhibition continues to remind us of the deep connections between creating and meaning making. I also want to draw attention to two important features that will be prevalent today. Both Stephanie Shih and our guest, Hideo Mabuchi, embody interdisciplinary paths. You have Stephanie Shih, who is a linguist professor and a visual artist, and Dr. Hideo Mabuchi, who is a physicist and ceramicist. Sorry, I'm not used to holding the mic. Let today serve as a reminder that fulfilling majors, careers, and our lives emerge when we integrate the full range of our interests and abilities. As Director of Art Museum and Galleries, my role is to embody our mission and to facilitate an interdisciplinary appreciation for our art, history, and culture, to facilitate conversation, and to provoke and foster curiosity. This is all demonstrated in the ways in which Stephanie Shih's exhibition, body of work, tells the story of how our export collection came to be, and how today Dr. Hideo Mabuchi will demonstrate his own body of work. But for students in particular in this audience, I encourage you to see this talk as an opportunity to reflect on how you might embrace a more expansive and interdisciplinary approach to your own academic and creative pursuits. I'm thrilled to welcome Dr. Hideo Mabuchi, a scientist, art director, and artist whose work beautifully illustrates the intersection of art and modern science. For this next bit, I will hand the podium over to Nora Kuhn, who's class of 2026, who will read Dr. Mabuchi's bio. Nora is not only an engaged member of the W&L community, she is part of the inaugural Museum Student Engagement Committee and serves as our communications officer. She will, like I said, speak slightly about the organization, but also pass the mic on to Dr. Mabuchi. So, Nora, you'll want to hold this closely.
Yes. Hello, my name is Nora Kuhn, and I serve as the Communications Officer for the Museum Student Engagement Committee. The Museum Student Engagement Committee works with the museums at W&L to bring students into the galleries for educational and creative pursuits, inspiring a passion for arts and culture through events like this one. Thank you all for joining us in Dr. Hideo Mabuchi's presentation of Embodied Narratives, Surface and Depth, Abstraction and Presence. Dr. Mabuchi will explore the intersections of science, art, and humanities through the lens of export porcelain. This lecture offers a rare opportunity to see how concepts in physics intertwine with art and broaden perspectives on how physicists can apply scientific inquiry and experimentation beyond the lab, engaging deeply with creativity, craft, and material culture. We will hold a Q&A session after the talk, so please stick around for that and engage. For those of you joining us virtually, please share your questions via the chat feature. Follow us on Instagram or Facebook to stay abreast with our programming like this one, student internships, and work opportunities. Our handle is wlu.museums. And now to introduce our incredible speaker for the evening. A physicist by training, Dr. Mabuchi explores... Dr. Mabuchi explores a nexus of conventional scientific research, craft as both a dedicated ceramicist and occasional textile maker, interdisciplinary humanities from a home base of aesthetic philosophy, new materialism and literary theory, and integrative education. Dr. Mabuchi teaches and directs a research laboratory at Stanford University as a professor of applied physics. His group's sponsored research focuses mainly on quantum optics and physics of computation, while his personal research further extends to the science of traditional craft materials and processes. Dr. Mabuchi teaches undergraduate courses that center craft and student making and bridge STEM fields with the arts and humanities. He currently serves on Stanford's Public Art Committee, Undergraduate Advisory Committee, and committee in charge of the program in Modern Thought and Literature. He's currently appointed as the Denning Family Director of the Stanford Arts Institute and Chair of Stanford's Breadth Governance Board. Dr. Mabuchi was born and raised in Massachusetts, received formal degrees from Princeton and Caltech, and served on the Caltech faculty for 9 years before moving to Stanford in 2007. In 2000, he received a fellowship from the John D. and Catherine T. MacArthur Foundation, which brought him into community with invaluable new mentors and role models. Thank you, Dr. Mabuchi, for joining us this evening.
Thank you. I'm going to use this, I think. Thanks. Thank you. Thank you for the kind introduction, and thank you, Isra and Jessica, Rachel, for the opportunity to be here and to offer this lecture responding to Stephanie Shih's incredible show, Long Time No See. For my title slide here, I've borrowed Stephanie's photo of Chinese export porcelain from the Reeves collection as arranged for the installation view of the Rose piece over in the galleries. And up in the corner, I've also quoted a detail from the Rose piece photograph itself, which was up on the screen just a moment ago. This detail, this detail up here, which I've taken the liberty of altering a bit, focuses on one of the silhouettes of porcelain objects cut out from the still life photograph, right? So these objects were originally present in the flower arrangement, and after the photograph was printed, Stephanie went in and cut them out with an X-Acto knife for reasons that she eloquently explains in her artist talk, which you can still access as a video recording on the W&L Museum's website. So it only takes a second to match the silhouette with its subject below. But even if there weren't a reference image of the thing itself on the slide, we would still, I think, naturally see the cutout hole as a teapot, maybe even as a china teapot. And this aspect of the cutouts really grabbed my attention the first time I saw images of Stephanie's work from Long Time No See. Hollow outlines of tableware transparently denote abstract categories such as teapot or urn. And categorically, we know what type of thing has been removed, and that's enough to start thinking about what the extraction might be meant to signify or provoke. But what about the excised thing itself? Doesn't it carry away something significant? What stories, what entanglements are embedded in the substance of a porcelain pot? If I were to hand you the actual pot, rather than just show you its outline or even a full image of it, what distinct narratives would the material itself embody? In her artist talk, Stephanie sympathetically personified these pieces of Chinese export porcelain, describing them as immigrants themselves, fellow members of the diaspora, with ongoing biographies and lives that we humans are positioned to care for. As someone who makes and studies ceramics, I wanted to modulate and amplify this by following a suggestion made by Tim Ingold, which is to tell the stories not just of categories of things, such as Chinese export porcelain or teapots, but also of the specific materials those things are made of. So I've taken it as my challenge to tell some stories about porcelain, how it has been caught up in the currents of the life world and its processual and relational properties. Diaspora and acculturation will be constant refrains throughout. And to get started, I thought I could show you a selfie I recently took in an airplane bathroom. So the main features of interest here are actually the blue and white houses on the bathroom wall. Back in January, I had the rare treat of flying transatlantic business class on KLM Royal Dutch Airlines. And towards the end of the flight, an attendant brings around a cart of small ceramic blue and white houses, which are actually small bottles of jenever, which is a traditional Dutch alcoholic spirit, kind of like gin. And you get to choose one to take home with you as a souvenir. The houses depicted on the bathroom wall here are representations of these little jenever bottles, complete with the yellow wax seals. So here's a photo of the one that I picked, including the facade and also the labeling on the bottom. The 97 here identifies which model this is within the full range of KLM houses, and I would assume that the 2024 notes when it was made. These are said to be produced in the tradition of blue and white Delftware, a type of Maiolica pottery that was for centuries seen as a symbol of the Netherlands. There are by now a total of 105 different models of these KLM Delftware houses. KLM issues a new one every year and has a phone app called KLM Houses that provides descriptions of them all. They're supposedly all models of real houses, although the reference of some of the earliest ones are no longer known. When the attendants on my flight were offering the little house-shaped jenever bottles around the cabin, I was curious to overhear one of them say that the real houses on which they're modeled are mostly located in the Netherlands, but with a few of them from its overseas territories. And a quick skim through the KLM Houses app turned up this one, for example, number 85, located in the city of Willemstad on the Caribbean island country of Curaçao. The Wikipedia entry on Curaçao tells us that the island's first known inhabitants were of the Arawak and Kakatio peoples from South America, that Curaçao was colonized by the Spanish around the turn of the 16th century, and that the Dutch West India Company invaded the island in 1634. The entry states that from 1662, the Dutch West India Company made Curaçao a center of the Atlantic slave trade, and that wealth derived from chattel slavery was used to build, quote, impressive colonial buildings in the capital of Willemstad, the city where the model for Delft Blue House number 85 is found. This allusion by the Delft Blue Houses to European imperialism reminded me of another colonial entanglement with blue and white ware, which I learned about during a research trip to Japan just last summer. In one of the museum exhibits distributed throughout the historic Dejima district in Nagasaki, there's a large reproduction of an etching from 1818 showing the city of Batavia on the island of Java, located where the Indonesian city of Jakarta now sits. I was struck by this image of a full-fledged European city transplanted into the Asian sphere from a colonial era concurrent with the age of samurai in Japan. Just as Willemstad, Curaçao was established as a regional base by the Dutch West India Company, Batavia was developed as a capital city by the Dutch East India Company, also known as the VOC, these being the initials for the Dutch name of this company, which I won't attempt to pronounce. The Wikipedia entry for Batavia tells us that in the 18th century, over 60% of Batavia's population were enslaved people working for the VOC. During the 17th and 18th centuries, VOC trading vessels would have sailed from Batavia to Japan. So that's basically like from here up to Dejima, which is up here. So they would have sailed from Batavia to Japan and traded at Dejima for goods including blue and white porcelain ceramics made in nearby Hasami, such as these bottles here, which I don't know if you can make it out, but they're labeled Yapanch Zaki. So I guess they're sake bottles. So these kinds of bottles, this blue and white porcelain, would have been among the items traded. And it's interesting to think of the Delft Blue Houses filled with jenever relative to these blue and white porcelain bottles of Japanese rice wine. Indeed, Dutch Delftware ceramics are said to have been inspired by porcelain wares brought back from Asia to Europe by the VOC. As stated by this informational website, hosted by a consortium of Dutch museums, Delftware was initially developed in the Netherlands as a visual simulacrum of blue and white porcelain using local materials and methods, because the technical secrets, which is to say the advances in material science required to make true porcelain, were unknown to Europeans at that time. So here on this slide, we have 3 images of blue and white ceramics from the 17th century. A Chinese piece all the way on the right from circa 1620, a Japanese piece in the middle circa 1670, and a Delftware piece circa 1680. Similarities in the style of surface decoration are evident, but what you can't see from these images is that the material qualities of Delftware versus Asian porcelain of that time are really very different. Porcelain is much denser and harder than the clay body used for Delftware, comprising different types of clay and flux materials that withstand and require firing to much higher temperatures. High-quality porcelains are vitreous and translucent, giving their surfaces a kind of visual depth that contrasts with the white flatness of the tin glazes that cover traditional Delftware. And just as a passing note, there's a new acquisition in the Reeves Gallery of a Delftware plate, and it's really interesting to go and look at that relative to the export porcelain elsewhere in the gallery. Nevertheless, to a casual eye, these 3 plates might seem to be of uniform kind, or at least close relatives, based on the general characteristics of the surface decoration. There are subtle differences. The Chinese plate features rather loose, quick brushwork, whereas the Dutch product seems much tighter in line and composition. And presumably this reflects the economic context of the Chinese plate having been a type of mass-produced export ware, perhaps combined with East Asian cultural aesthetics favoring fluid brushwork, as opposed to the Dutch ware intended to proffer domestic substitutes for exotic Oriental goods. I also think it's interesting to consider the kind of metalepsis in which the specific flowers and animals painted on the Chinese and Japanese ceramics would have carried very specific cultural connotations, whereas in European compositions, they would have served mainly just to invoke Chineseness and Oriental allure. So on a visit to the Toto Museum in Japan, Toto, the toilet manufacturer, back in 2018, I was fascinated to see these early examples of Japanese porcelain toilets decorated in a style strikingly similar to that of blue and white tableware. Inasmuch as the use of porcelain for sanitary fixtures seems to have originated in the West, one wonders how such disarmingly familiar surface ornament might have been intended to ease the recasting of a prodigal Asian material in an unfamiliar and, in a sense, sullying functional context. So whereas the blue and white ornamented surfaces on Delftware might have sought to exoticize familiar forms of dinnerware for cosmopolitan Dutch consumers, perhaps this decoration sought, in contrast, to naturalize the use of porcelain for making latrines for early modern Japanese who were already reeling from the frantic pace of governmentally mandated westernization. So does all this point to a kind of superficiality in the way we perceive things of foreign origin? With the previous slide, is an appropriation of the blue on white surfaces of imported china good enough for European domestic consumption, even if the deeper material qualities of porcelain, translucence and durability, are lacking? And on this slide, is a familiar Japanese skin somehow crucial for promoting the acceptance of presumptuous foreign ways of exploiting porcelain's durability and glassiness, which makes it easy to thoroughly clean? So as we continue into the next part of this talk, I'll try to center these sorts of questions around surface, depth, and cultural translation within our agenda of telling stories about porcelain as a material, and not just the outlines or appearances of the things that are made with it. So what is porcelain, anyway? For centuries, through the early modern period and into the early Industrial Revolution, porcelain was an advanced technology, discovered and refined in China, reproduced on the Korean peninsula, taken by force to Japan, and coveted by European monarchies. We'll soon look at a timeline of porcelain development around the world, but first let's consider this display from the Aichi Prefectural Ceramics Museum in Japan that pairs examples of advanced Chinese ceramics, such as celadon glazed porcelains, with synchronous Japanese attempts to mimic them. The ewers in the foreground, for example, these guys, which date from the 13th to the 14th centuries, if you look at this celadon porcelain on the left, it seems really, its technical superiority seems really pretty profound relative to this kind of domestic imitation on the right. It's a little bit hard to see in this lighting, but the Celadon sky blue glaze on this ewer to the left, it's very smooth and uniform in color. The glaze pools a little bit on the edges of the relief pattern on the surface of the ewer, so it's a little bit darker around the outlines. It looks more like a modern piece of produced fine china. Whereas this piece over on the right, this attempt at reproducing those sorts of Chinese wares was being attempted in Japan at a time where people didn't even really understand what glaze was. I think for kind of people in pottery, you learn early on that the easiest way to make a glaze is just by combining wood ash with some of the clay that you're using anyway. And so what most people assume is that the whole idea of glazing was initially discovered when fly ash in wood-burning kilns would fall on the surfaces of pots. And when it got hot enough, those would actually fuse and form a glassy surface. So you can make ash glazes in that way. Just take some leftover burnt wood ash, combine it with your clay, and use that slurry as a kind of glaze to apply on your surfaces. But those sorts of very rustic glazes, they run, so you can really see that there's a kind of muddy green color to this glaze, which is what you'll get if you don't try to strictly control the composition. And there are little rivulets of it running down the side of the pot, which kind of go counter to the actual impressions that are made on the surface of the clay itself that are trying to form their own pattern. Very, very different than what you have on this piece here. Now, having said that, this piece on the right, the Japanese domestic product, it has its own actually interesting aesthetics, which personally, for my taste, I prefer those in a certain sense. But it's what I'm going to try to bring out in some of the subsequent slides that ties back to this is that it's interesting to think how the cultural aesthetics around traditional craft, they kind of evolve hand in hand with the technologies and techniques of production. So whereas you might see the piece on the right as being rustic or even rougher, maybe you would even say that the lack of people's ability to directly reproduce the very fine imperial porcelains that were sometimes imported from China, that led in and of itself to the development of a craft aesthetic in Korea and Japan, which kind of you played a large part in developing what we think of as the wabi-sabi aesthetic around the tea ceremony in the Japanese cultural frame. So anyway, so porcelain for many centuries was an advanced technology. And porcelain technology was eventually brought to Japan. And really, it was plundered by invading forces during Hideyoshi Toyotomi's ultimately futile military campaigns on the Korean peninsula in the 1590s. Large numbers of Korean potters who knew the secrets of producing porcelain, large numbers of them were forcibly relocated to the Japanese archipelago. And these captive potters brought their knowledge of constructing and firing high-temperature kilns, as well as the ability to recognize and blend special ceramic materials required to compose porcelain. In our modern understanding, there's actually no unique recipe for porcelain, which is to say there's actually a very broad family of material compositions that can all achieve the material qualities we associate with the term porcelain, being vitreous, being very dense, being translucent, being very white. So on this timeline here, this earliest development of porcelain-type ceramics occurred in northern China. And really that development took place over millennia. Right, so here's an excerpt from a great book by Nigel Wood called Chinese Glazes, which actually talks also quite a bit about the development of porcelain clay bodies in China. And you notice that the time frame that Wood cites is 13th century BCE to 7th century CE, so really kind of 2 millennia. And I believe what that's meant to refer to is that the first white stonewares that you see in the archaeological record in northern China that are kind of proto-porcelains, those are all already emerging in this kind of 2nd millennium BCE. And then if you are generous about it, you can sort of see a continuous attempt at developing that material and the kiln technologies until around the 7th century CE, you start to see the very first things that we would think of as being true porcelains, fully vitrified and translucent and very white. And what's remarkable about that development of porcelain in northern China was there actually were places there because of unique conditions of geology that you could kind of put your shovel in the ground and dig up something that was really like a porcelain clay body. And so, you had to kind of understand what that was, how to find it, to do certain kinds of refinements with it, and then you had to understand how to fire it to extremely high temperatures. But that's like almost a unique place, as far as I know of, where really geology kind of produced a porcelain clay body for you. You just had to harvest it and know how to fire it. A lot of what we really think of as the classic Chinese porcelains, though, are from southern China. And the single place which is most prominently identified that would be Jingdezhen. And so the Jingdezhen porcelains of great fame, emerging around, let's say, the 10th century CE, these were actually intentionally composed clay bodies made from two very distinct materials. And there's this interesting quote here where Nigel Wood again, but this time in this is actually in a letter, some kind of correspondence that was published in Ceramic Review. It says that the Chinese speak of the bones and flesh of porcelain, with the hard, in the sense of high firing kaolin, as the bones, and the soft or lower firing porcelain stone as the flesh. And so this is a very interesting thing about porcelain that a friend of mine had to explain to me so that I could understand what was really being said in this letter, that, you know, we think of porcelain as being a kind of clay, and for sure you need some clay in there. And the clay that goes into it has to be able to fire to very high temperatures and needs to be very white. It needs to be very low, in particular in iron and titanium impurities. But actually, the thing that makes porcelain is not the clay itself. It's actually the feldspar that's in there, or something like a feldspar. And so the naturally occurring material that they found around Jingdezhen was something that now gets called porcelain stone. And that's not really a clay. Like, if you were to just take the porcelain stone and grind it up and try to make pots with it, it's really horrible to try to shape. Like, it's not very plastic. You can't shape it the way that you can shape clay. What's nice about it is that when you fire it to the right temperature, it becomes this glassy, translucent, very kind of ghostly sort of material. It's a beautiful kind of glassy material. The thing is, you know, you can't really shape it very well on its own. And what somebody explained to me once was that when you're firing it, it has a very narrow temperature range in which it fires to this vitreous translucence. If you underfire it, it doesn't get there. It's not glassy, it's not translucent. If you overfire it, it basically slumps and melts. So this business about bones and flesh, so by adding the very pure white kaolin clay into the porcelain stone, it makes the composite material very plastic so that you can shape it. And the kaolin in there drastically broadens the firing range, right? Because in any kind of pre-industrial technology kind of kiln, you're not firing your kiln to the same temperature everywhere in the kiln. Like from the back of the kiln to the front of the kiln and from the ceiling to the floor, you have very widely ranging temperatures. So if you actually want to be able to fire an entire kiln load of porcelain and have all of it turn out pretty much okay, you really need this composite material that kind of gives you the best of the qualities of both the kaolin and the porcelain stone. So they're really, you know, I think at that point you can really say that there's some interesting material science development happening there. Sources that I could find online would date the achievement of this kind of porcelain technology on the Korean peninsula also to something like the 10th century. And then in Japan, here's a quote from the Museum of Oriental Ceramics in Osaka, and this basically tells the story that I just mentioned about how skilled potters from the Korean peninsula were brought by the retreating military commanders in the wake of the Imjin Wars to bring that technology to Japan. And for many years, as the VOC and other entities were kind of bringing porcelain from East Asia into Western Europe, a kind of craze developed for collecting that sort of porcelain among wealthy people and monarchs. There was really very intensive effort to try to reproduce porcelain, like true porcelain, in Western Europe. And, you know, that's the subject of books that people have written and a whole other talk. But it really took centuries for people to really figure out how to do that. And as I understand it, the first place you can see that being achieved was in Meissen. And so here on Meissen.com, you can see on 15 January 1708, the first European white porcelain was fired. Okay, but now if you fast forward to kind of like contemporary ceramic practice, if you just ask a contemporary potter, what's porcelain, where do you get it? People will tell you things like, oh, porcelain, yeah. So it's usually considered like an equal part mix of 4 different things. So you have 25% kaolin clay, 25% ball clay, 25% silica, and 25% some kind of feldspar. And variations on that will give you porcelain-like clay bodies that have slightly differing properties. I think this is really interesting. This is this fellow named Derek Au spent a lot of time in Jingdezhen working with the Jingdezhen porcelains and developed this great website where people can kind of post their recipes for both clay bodies and glazes. But I think the things that are printed here are really interesting. So if I just try to read from the screen, this post says, back in the US, I've struggled to find a porcelain clay body and glaze that I was satisfied with. But after hundreds of tests and failed attempts, I finally have something that comes close to the quality of what I had been accustomed to in China. So for example, in the next paragraph, the body is very white and fairly translucent. And then there are these interesting kind of trade comments. The 1.5% additional V-gum tea improves plasticity somewhat, and running the clay through a vacuum pug mill is essential to getting a workable porcelain body. Right, so making porcelain, if you want really good porcelain, it's kind of an involved technical thing. And then if you look at the actual recipe that he posts on the bottom of the slide here, so it says 29% silica, and there are actually many places you can source your silica, but then it very specifically says 29% New Zealand halloysite, which is a kind of kaolin, 22% Mahavir potash feldspar, 12% superstandard porcelain kaolin, and 8% Graulig kaolin. And so if you look at that ingredient list, you've got stuff from New Zealand, you've got stuff from India, and you've got stuff from England, from the UK. So in modern practice, where people are trying to compose and work with porcelains that they feel have that are really good examples of the defining qualities of porcelain, these involve materials that are sourced from all around the world. So if you kind of go through this timeline from the original developments of porcelain in northern China to the way that we think about porcelain in modern craft practice today, so porcelain kind of originated in generational efforts of artisans to explore and express the affordances of local geologies, right? Things that they happen to just find in hillsides and valleys in their local environment. But it's evolved today into something that's very kind of normative. Like we have an idea of what porcelain is supposed to be. It's optimized. Like people will just tweak these recipes and sometimes have 7, 8, 9 different components that go into the clay body. And they're placeless, relying today on global supply chains. So just to say a little bit more about kind of clay and place. So clay is just weathered minerals of the Earth's crust. And when I'm traveling in interesting places, I like to try to keep an eye out for wild clay. So this photo is actually from Iceland. This is a glacial plain. You can see a couple of glacier snouts in the distance. And walking around here, I happened to find just a wash of nice clay on the ground. And so I just picked a little bit of it up and made a little ball and set it on the boulder in the foreground and kind of took a photo of it, a portrait photo of the clay in its natural environment. And clay is found all over the world. I mean, you have to be kind of lucky to be in a place, to live in a place where there's really good clay for making pottery or ceramic sculpture that can fire to high temperatures. But in fact, the Atlantic seaboard is a great place for clay. I, in some of my classes, use clay from Starworks, which is from North Carolina, just a few hours south of here. And Starworks actually, what I love about the clay bodies that they sell is that they're kind of close to wild clays. Like they harvest wild clays and process them very minimally and then package them for sale. But they're really, they really retain their kind of sense that they came from somewhere specific. They keep a lovely natural color and they use a special process to really leave a lot of the grit in the clay that naturally occurs. But they also have really great working properties and they're really great clays to wood fire with. Starworks doesn't make a porcelain. I know everybody would love it if they would try to make a wild porcelain. I just imagine that they don't have access to the right kinds of clays to do that. There's a whole story about Cherokee kaolin and the ways that was once exploited by people in the UK. That's another sideline that I don't have time to go into today, but maybe just note in your mind that there is a local story about kaolin. Here's another travel photo, this time from the Mediterranean island of Kimilos. And so this is actually like a giant kind of, I don't know what to call it. It's a huge formation of kaolin. Like if you look down, I should do this with the pointer. If you look down here, That's like a little cave that people could crawl into. And what we learned from people who knew about the history of this place is that for many generations, locals on the island have been harvesting this kaolin, not to use in ceramics, but to actually use in brightening their laundry. So kaolin, there are sizable natural deposits of kaolin in the Mediterranean region. And it's been known as a ceramic material since at least the second millennium BCE. So similar to the time that we were talking about when the first proto-porcelains were being developed in northern China. And so, for example, in this middle photo here from the, where's this from the Met? So this is an example of what's known as Cypriot white slipware, where the actual clay body of this jug, it's not a porcelain jug, and the clay body itself is not really based on kaolin, but just kind of like a paint of kaolin was applied in stripes on the surface to make this contrasting white, this white that contrasts with the darker color of the clay body underneath. So I find that very interesting that kaolin was known as a ceramic material in that kind of second millennium BCE, both in the Mediterranean cultural sphere and in northern China. But then if you try to trace like whatever happened with kaolin in the Mediterranean, it doesn't seem that there was ever a sustained attempt to develop a white clay body from it. Right? Mostly it got used as a surface decoration. And probably the best known example of where kaolin shows up in the famous kinds of Greek pottery is, what's best known, I think, is the classic Athenian red figure and black figure ware. Right? So these are actually terracotta, lower fire, very high iron clays, which actually, there's another whole interesting story about how both the red parts and the black parts of the surface are exactly the same clay, but the black parts are just much finer particle size. And if you can kind of separate out the fine particles and use them as a paint and leave the coarse particles for making the clay body, then with a certain kind of firing, you can actually get this very strong color contrast. But a little bit later on, you come into the so-called white ground lakithoi, for example, where kaolin was used on the surface of these pots, again, not to make something that was like porcelain, but just to kind of fire on a white background, which would then just be like a white background for polychrome painting afterwards. And I'm not really an expert on this kind of Greek material culture, but you get the feeling that, I'm told by colleagues that, with this sort of pottery, the actual forming of the vessels, so pottery itself was not really considered at the time as a particularly high art form. Painting was really what was considered the high art form. And somehow going along with that was a kind of a disinterest in the idea of making more interesting clay bodies. But what was emphasized apparently was trying to develop better surfaces for people to paint on. So if you try to wonder, well, what was different about cultural aesthetics at that time in China? This is again a little bit of a speculation, but it's hard to ignore the correlations of porcelain and jade. And you can find scholars who have written about this, but to just jump to a contemporary example. So the image on the upper left on this slide. So those are pictures of the bronze, silver, and gold medals that were given out at the Beijing Olympics. And what I find really interesting about it is that the precious metals are actually inset into jade. And jade comes in different colors. But if you look at the bronze medal, so the bronze medal is set into green jade, or this even kind of very darkish green jade. The silver medal is inset into a lighter green jade. The gold medal is set into white jade. And so if you look at examples of, on the lower right of this slide, there's an example of a jade bowl, an Nephrite jade bowl. And then in the center lower panel, just from some contemporary commercial website, there's a picture of a very nice, thin, translucent porcelain bowl. You can kind of see how there's a kind of similarity in the kind of inherent material qualities of porcelain and jade. And I think jade at that time, really these particular, so here's a quote here. As for jade, the gentleman compares it with virtue. The way it is warm, smooth, and lustrous resembles Ren. The way it has structure and contains patterns resembles wisdom. The way it is firm and unyielding resembles Yi. So there was something about the culture there where there was an appreciation for the qualities of materials themselves, without necessarily the need for putting anything, any kind of representational painting on the surface. What's interesting for me, though, is like, when I go to museums, I love to see the Chinese jade objects that are there. I am generally not so interested in those pure white ones. What I really love about jade are examples like the one shown here on the left side of the slide. So this is from the Metropolitan Museum of Art, a very old jade disc. But this is jade that's not pure uniform white translucent, but rather you can just imagine this thing having been cut from a large piece of rock, right? It's got these veins of impurities and very I don't know, to me this is like a really metallic, rusty kind of red color. So the source of impurities, right, the real character that you can have in a piece of jade, that's what I really love about the old Chinese jade objects. And there's a way that porcelain answers to that. So this piece that's photographed over on the right side, this is a piece that I have in my collection. Like here's that KLM Delft House number 97 in the background. But this thing here, this is a contemporary tea bowl made by a living American potter named Jack Troy. And Jack was really, I think, one of the first people in America to really start wood-firing unglazed ceramics in what people would generally think of as more of a Japanese tradition. And so this particular tea bowl is actually made from a very nice, clean porcelain. So if you turn the tea bowl over and look at its bottom surface, so I don't know if you can make out, but there are 3 sort of white discs on the bottom, and the areas around it are darker in color. So where those white discs come from is that typically when you're firing pots in a wood-burning kiln, you're setting them on shelves so that you can stack a lot of pots into the kiln. But you need some kind of like very refractory spacer to keep your pots from just fusing to the shelf. And so where the pots are sitting on little balls of wadding, what we call it, those parts of the bottom of the pot are really shielded from exposure to the kiln atmosphere. And so in this particular case, those parts of the surface of the porcelain tea bowl were shielded from the kiln atmosphere and stayed very white. There are some drips and things here which are really melted ash, kind of in a way that I referred to in an earlier slide. But what really interests me are these kind of bronze, orange, brown regions here, which they're not covered in wood ash. That's not where the color comes from. It's really the bare porcelain still. But something about the chemical reactions that have happened on the surface of the porcelain while it was in this wood-burning kiln transformed it from the very pure white that you might think would be what was desired into a deeper and warmer color. And so this is the thing that I think is really interesting about the contemporary ways in which we're using porcelain, that we're actually no longer particularly after the translucence, the whiteness. Rather, we're really interested in the way that it interacts with the atmosphere that you have in a wood-burning kiln. And it reminds me a lot of this kind of other side of jade, where what we're interested in is the kind of individual and kind of serendipitous character that comes from kind of flaws and inclusions. So I want to take just a minute to talk a little bit about wood firing so that I can give you some context for what I just talked about. So here's a picture of a wood kiln that I fire with my crew of fellow artists. So what we're looking at here, the most important part of a kiln is the chimney. So the chimney on this piece is at the back here. It extends up off the top of the screen. The place where we introduce wood into the firebox, where we're really actively burning the wood, that's over here. And then this area in the middle is what we would call the stacking chamber. And in fact, if you look, there's kind of an arch here. So all of these bricks that are in this arch, those can be taken out. So this is actually a door in the side of the kiln. So when we're getting ready to fire the kiln, somebody, usually me, crawls in there. People hand me pots, and then I'm stacking them on shelves to fill up the stacking chamber. And actually, the way that you do that is really super critical because the density of the pots in there it really controls the way that the kiln draws. After you're done stacking the pots in the stacking chamber, you can re-brick up the door and you're ready to fire, and then you start introducing wood into the firebox and the temperature goes up and up and up. And really, to fire porcelain or other kinds of high-fire stoneware clays, just by burning wood, you need to be getting the temperature in the kiln up into the range of 2300, 2350 Fahrenheit, so maybe 1300 Celsius. Here's just like a little video of what it's like stoking the kiln. And it's like, I'll just show you this because it's a really big fire. Yeah, by the time the kiln is really at its highest temperatures, if you were to just hold your glove in front of the open door like that, it would catch on fire. It's a super fun process. If you like fire, you love wood firing. But you can just imagine. So this part in the film, that's this structure right here. So you're burning this wood, and what we'll typically do is over the course of maybe 50 hours, we'll burn like 2 to 3 cords of wood. So we're burning really quite a lot of wood, and so you can just imagine that the ash and all the chemicals that come out of wood when you burn it, those are, the pots in the stacking chamber are kind of bathing in it, right? Because all that stuff is coming from the firebox through the stacking chamber and then up out the chimney. Let me just add, in case any of you are wondering, in contemporary practice, you would never cut down a tree just to wood fire. So, for example, where we wood fire, it's at a place where they're doing forest management, taking down pine that's been beetle infested or other wood that needs to come down for some reason, and that's the kind of wood that we use to do this sort of wood firing. Actually, wood firing was the thing that really got me hooked on ceramics. When I started making things, I was drawn to throwing pots on a wheel, but wood firing was the thing that really sealed it for me because I suddenly saw this connection back to physics. And so this pot that's shown, this kind of like round bottle sort of thing that's shown on this slide, this is a kind of porcelain. It's a funny porcelain composition that I put together kind of as an experiment, but it developed like a really, really deep kind of vermilion red color. You can still see, like on Jack's tea bowl, you can see some white spots here of where it was sitting on its side on the wadding. But I just want to, there's another whole talk in all of this, but around the time that I started wood firing, I started to wonder, has anybody ever looked into the physics of how this color develops in a clay like porcelain? So the main thing that I could find was an extensive body of work done by some Japanese material scientists and chemists. So Kusano is the kind of leading name here on this review. And so they use electron microscopy techniques to really unravel the kind of process by which these red colors formed. And so inspired by these articles that I was reading, I was able to kind of bring samples back to Stanford and use equipment that we have there to kind of just look at these red surfaces at very high magnification and reproduce or kind of confirm, or I don't know what to say, kind of refine things that the Japanese team had discovered. So maybe the most interesting thing about it is this surface just looks more or less uniformly red to us by eye, just looking at it. But if you take little samples and stick them into a microscope, this is what you see on those sorts of surfaces. And so it looks a little bit like a mess, but hopefully what you can make out is there are structures here that are like stacks of hexagonal plates. Like if you can imagine like clear glass hexagons where you've painted just the rims of the hexagons red and made like stacks of them like a deck of cards and fan it out. Those are the sorts of structures that you're seeing here. And so what the Japanese team figured out is that what forms on these porcelain surfaces in the wood firing are you get larger hexagonal crystals of alumina, which is actually, it's the pure clear form of sapphire. But then those hexagonal alumina crystals actually template the growth of smaller red hematite crystals, red iron oxide. So in the TEM images that the Japanese team is collecting, that'll look like this, where the central alumina crystal is this thing labeled C, and the red things are labeled H here. But it turns out if you go with the right kind of optical microscope, you can actually see that in color, right? So you can see the red rims here developing around the clear hexagons. There's a kind of yellow haze in the background, which is something else. But it's really these red rims, when you have enough of them and they're dense enough, they give you this overall red color forming on the porcelain. And what this experiment was to go back, on an earlier slide, I said something like the standard composition of porcelain is 25% kaolin, 25 ball clay, 25% silica, and 25% feldspar. So the idea here was to just substitute the silica with alumina so that you actually kind of precede the material with a whole bunch of these little hexagons. And so that really makes that red stuff grow rampantly. Also using some of the very special equipment that we have at Stanford, I could go in and kind of focus in on just a single one of those hexagonal plates. And the most striking image is the one over here, where we used a very fancy tool called the nanosims. And what this thing does is to scan one of those hexagons and identify what atomic elements are present in the different parts of the structure. And so this is a false color reconstruction where what it does is where you have dominantly silicon, you'll have a green pixel. Where you have dominantly aluminum, you'll have a blue pixel. And where you have iron, you have red pixels. So you can really directly see that the central clear hexagon is an aluminum-based structure and that the rim is really distinguished by having a lot of iron. So this is one of many interesting physics stories that one can tell about color development in wood-fired clay. But in the context of this overall talk, what I want to try to reemphasize is this idea that, we have porcelain or other kinds of clay, and rather than kind of adding something onto the surface by painting on it, wood firing is this very different sort of approach where rather than covering up your clay to give it new clothing, you're treating it in some way that it expresses kind of inherent material properties, and that turns into the color, right? You're not putting color onto the clay, you're just causing the clay to develop its own color. And that's a kind of material expression that I really like just from, it's really neat as a physicist, but it's also the kind of thing that I really like to work with as a maker. So I just want to show a few slides of my own work here. And so this is what's shown on the left is just a thrown and altered piece, this is not porcelain, but it's rather a clay body that I composed trying to make something that was an interesting workable clay body using mostly Northern California clays. Above and beyond wood firing, kind of what I like to do when forming pieces is I like to kind of learn through trial and error about the interesting things that clay does on its own as a material. So for example, if you look at this spout of this bottle type form, there are these kind of wrinkly sort of things. And those are not, I didn't make those with a tool, but rather like if you're throwing a piece on the wheel and you open it out to a large diameter and then you kind of force it to narrow back down while it's spinning on the wheel, there's like a lot of surface area on the inside of the spout that has to go somewhere when you neck it down. And it turns out the thing that it does is it starts to wrinkle and ripple like that. So I really love that effect. And often what I think about what I'm doing is I'm trying to frame that behavior in some aesthetic way. And so the photo on the right is the same exact piece with a top view, just showing what it looks like after it was wood fired. And what I really love about it is that I don't have to cover up those wrinkles with a glaze, but rather the wood firing process just it stimulates them to develop their own color. And often, because it does have something to do with the way that the kiln gases are flowing over the material interacting with it, it tends to highlight those kinds of wrinkles and the edges of a lot of those structures. Exactly the same clay, just fired in a different way. You can actually get surfaces that are much more like a pure dark gray or black. And sometimes I'll make forms that sort of work better with that sort of pure black. And then here's some other examples of, like this one on the left is really, this is fired in Utah State University. Sometimes if you have the right kinds of wood and seems to also have something to do with the amount of water that's present in the kiln, you can even get these colors that are tending off towards greens or rusty oranges. I think some of my favorite results that we get in that kiln that I showed you that we fire in California are these sorts of bronze colors like this piece in the middle, or the kind of combination of the really dark with just a little kind of haze of those more bronze-like tones in this piece on the right. Okay, so I'm running down on time. So I wanted to kind of come back to this place that we started and return to this question that I asked at the beginning. What stories, what entanglements are embedded in the substance of a porcelain pot? So the first ceramic piece that we investigated, the KLM Delft Blue House, was not actually porcelain, but it was a type of low-fired tin-glazed pottery known as Delftware. And in retracing how Chinese blue and white export porcelain came to influence the development of Delftware and its canonical color scheme, we found pathways entangled with Orientalism and European colonialism and traversed storylines of porcelain as an advanced technology targeted by state-sponsored industry in Europe and military conquest in Japan. A second narrative cluster gathered around this wood-fired porcelain tea bowl, which drew together porcelain's historical origins as a craft material the variable ways in which clay bodies with porcelaneous qualities can be composed from different mineral resources, the influence of regional cultural aesthetics on the development of material technologies, and some new developments in the 1,000-year arc of porcelain ceramics that is prizing the non-whiteness that porcelain can achieve in wood-burning kilns and glimpsing the kind of amazing nanoscale physics that underlies it. So to end where we started with this, with Stephanie's photograph of this assemblage of export porcelain, I hope we've managed to extend, at least a bit, the metaphor she developed in her artist talk of ceramics as fellow diasporans. Porcelain itself, as a technology and as a material paradigm of visual and haptic qualities, immigrated long ago from the Asian sphere and has circulated and acculturated globally, evolving over many generations of manufacturers and makers. In our time here today, we've barely scratched the surface of its entanglements with human history. So whatever your main fields of interest are, I hope you'll keep an eye out for porcelain to make an appearance. And whenever you next encounter a fine craft object in a gallery or an actual household use, I hope you'll be primed not just to admire it as an exemplar of some curatorial category, but rather to experience its thingy presence as what Korean philosopher Byung-Chul Han refers to as a cipher, as in C-I-P-H-E-R, a cipher for the terrestrial order. Thank you very much for your attention. That's all I have to say.
All right, thank you so much. This was such an insightful talk. We can delve into some questions. We have about maybe 6 minutes. We have 2 mics, and we have a virtual audience. So if you have questions, please type it into the chat. One of our staff will read it aloud. Anyone else? Any takers?
Thank you very much for the talk. Quick question. You briefly touched upon Greek pottery. Did Greek pottery, did it develop in concert or sort of independently from the Chinese porcelain you touched on briefly?
Oh, as far as I know, those are completely independent. I think pottery as well as weaving, those are things that seem to have been independently developed by people around the world. Indigo dyeing is another really interesting example of that. And I love that just because it's like, those are the things that's the art that nature wants you to do. Nature gives you the materials and people figure it out.
Gotcha. Thank you.
I just had a quick question. Does it often take a lot of models to achieve the natural aesthetic you're looking for?
Yeah. I mean, I am the kind of maker who I like to just make a lot of stuff. And, I'll kind of decide later whether I like it or not.
So it's just like a lot of trial and error?
Sorry?
A lot of trial and error?
Yeah, a lot of trial and error. And there's a funny thing where, especially in this wood firing process, where you're not intentionally coloring the surface, but it kind of happens organically in the process. I always tell people, like, when your pots first come out of the kiln, you can't even really see them, right? The only thing that you see is how they're not what you were hoping for. But if you kind of put them away in the closet for a few weeks and then come back to them, that way you can see them more like a rock that you find on the beach, and you can just sort of contemplate the way that they turned out.
Nice.
Yeah. I actually end up with a lot of pots where I'm not sure whether I like them, and those are the ones that I keep around in my office.
Nice. Thank you.
Got one in the front.
Do a lot of Chinese porcelain pieces last a long time because they're very strong? So you have pieces from really ancient times. Does the porcelain make them able to, not be broken easily?
Oh, sure. So the question was, porcelain being such a durable material intrinsically, does that mean that Chinese porcelains survive better in the archaeological record? Ceramics in general is a very durable material. Unlike organic things like wood, paper, or cloth, if you don't break them, they'll survive in their fired form for hundreds of thousands of years, as far as we know. So porcelain is more durable, but in a certain sense, it's kind of like any other ceramic in the sense that if you drop it, it's going to break. If you don't drop it, it'll be around forever.
Hi, thank you so much for your talk. It was really, really interesting. And I particularly appreciated your shout out to hematite glazes because they're really cool. So I'm an archaeologist of Neolithic ceramics in Southwest Asia. So I have a lot of questions and comments. One of the things that I wanted to ask you about was this parallel between jade, which I thought was really interesting, that you'd sort of said that you thought the luminescent qualities of jade kind of may have inspired porcelain, but of course porcelain comes along like a lot later than the very earliest Neolithic jade in China.
For sure.
And in Southwest Asia, I wanted to point out, we actually have a parallel thing happen with obsidian. So it's not very well published or very well known. Elizabeth Healy is the main person who does it, but there are little tiny obsidian vessels in Southwest Asia that end up getting copied in this kind of ceramic called dark face burnished ware.
Okay.
And they burnish it.
Right.
They like burnish the exterior and they fire it in a reducing atmosphere
right.
to make it black. But I was wondering, like, why do you think, like, they're in Neolithic China and of course in Jomon, Japan, they're doing really different things at the same time that they're producing jade. Why do you think it takes like so long for that kind of inspiration to have an influence on ceramic manufacturing? Because it doesn't really come up, you mentioned it doesn't really come up until the second millennium.
Yeah, if I should have maybe been more precise in what I was trying to say. I mean, first of all, I'm not an expert in this, but I just find it very compelling that you're talking about a material culture in which there is a valuation of materials just intrinsically, right? And I would just contrast that maybe with what you find in classic Athenian pottery, where the value is really on the painting on the pots. So I just wonder whether, the development of white stonewares, using materials that they happen to have, driving towards the kind of really, I think the time that it takes to catch up is really developing the kiln technology to be able to fire to those very high temperatures. But it's just, I guess I'm trying to speculate that it's, in a culture where you already have an appreciation for the qualities of materials, independent of any painted representation, that's maybe the kind of culture in which people would push the development of a material like porcelain. Oh.
If you could go ahead and share the question like you did earlier.
Yeah.
We have a question from our live streaming audience. Hal Higginbotham asks, how do you find different varieties of wood in what ways do they affect the surface of porcelain in your wood firing?
Oh, yeah. So the question from the chat is how different kinds of wood affect the surfaces that one gets in wood firing. It matters a lot. And so you'll see there are big differences between firing with softwoods like pine versus hardwoods like oak. People in Australia that wood fire get very distinctive results with the sorts of woods they have there. And then you even find regional variations with the same varieties. Like there's a kind of a sort of famous anecdote in American wood fire where if you fire with cottonwood in Utah, because that's almost the only wood that you have, that cottonwood for some reason retains a lot of potassium. And so if you're firing not necessarily porcelain, but darker clays that have some iron in them, you get blue-gray surfaces almost without fail. But cottonwood in other parts of the country doesn't do that. So there's really quite a variation with the wood. And so it's the kind of wood that you're using and the way that you cool the kiln, those are things that have like a lot of impact on the color spectrum that you get.
First of all, thank you for your talk. And second, I have a question about jade. When you were talking about how you like the impurities in jade, are those common? And is it more revered like culturally to make jade with or without those impurities?
That's a really great question that I don't know how to answer, not being a Chinese art historian myself. I'll just speak personally that, when I go to the Fuhrer-Sackler galleries in DC, I mean, they have amazing examples of jades like that, and I really feel like the most incredible ones are the ones that are just riven with impurities, because they feel like, earth materials. I don't know much about the aesthetics of the time, but a lot of the artifacts that survive for us are in fact of that type. I would imagine it's hard to find large pieces of jade that don't have those impurities.
With your reddish bottle that you could see microscopically, there are different colors there. Does that end up giving you some depth to the color on the surface? You didn't really talk about that.
Oh yeah, no, thank you. I mean, we talk a lot in ceramics about depth of surface. To understand the term, it's sort of, if you think about a Coca-Cola can, that to me is a very flat red. Whereas the kind of reds that you'll have in certain kinds of ceramics is really much more like looking at a rock or something that has really a lot of color depth. And in fact, a surface like that has a pretty saturated red color, but when you're looking at it microscopically, it's funny, most of it is clear. And so there's a kind of clear glassy phase that has those little red hexagons embedded in it. And you actually, they're not dense. Once you zoom in enough, a lot of what you're looking at is actually clear. But there are enough of those kind of red pigment clusters that, your overall visual impression from a distance is uniformly red. So you're having to see quite a way into the surface to really get that overall, well, what should I say, as a physicist, the ambient light travels quite a ways into the surface to encounter those red pigments and reflect back to our eye. And in that sense, it is actually quite a lot like European oil paintings. What you're seeing is not literally on the surface, but you're seeing the kind of overall integrated effect of what's going on in the depth of the surface. Sure. So the question was about the kind of classic Greek red figure, black figure pots. I'm not the right person to ask about historically how it was discovered. I'm not sure that it's really known how that was discovered. I can tell you what we understand about how it's done, which is really that you take the kind of terracotta clays that they have, and what's thought is that they would be sort of separated, where if you just plunge them in quite a bit of water, the really fine particles will remain suspended at the top, and the coarser things will settle down to the bottom. So what we do in modern practice is you kind of put your clay with a lot of water into a plastic soda bottle, shake it up, and then let it settle. You kind of poke a hole near the top, and the stuff that runs out from the top has just the very fine particles. So that's kind of, you would dry that out a little bit, and that's what you would use for the black paint. The coarser particles from the bottom of the bottle you could make into a clay body. And so the thing about the clay body made of those coarse particles, it's really pretty porous, right? So when you fire it, if the kiln has a lot of oxygen in the kiln or only a little oxygen in the kiln, kind of in the depth of the clay body, it will know about that, right? Because that atmosphere kind of penetrates into the clay body. The really fine particles that are used for the paint, those really will seal over at the kinds of temperatures that people were able to achieve in the kilns of that time. So the sequence is something like, you fire those pots as high as you need to, and then at the very high temperature, you start to deprive the kiln of oxygen. And then at that point, what we understand is that all of the surfaces turn black because you have reduced iron oxide as opposed to hematite. But then in the cooling, if you let oxygen back in, that oxygen will be able to get into the porous clay body and turn it back to a red color, whereas the black paint is kind of sealed over and doesn't reoxidize. So, in that regard, it's a lot like some of these other processes that we're talking about. I mean, it all has to do with oxidizing or not oxidizing iron. But, that's an early and very well-studied example of interesting physics really influencing color development in ceramics.
All right. Well, thank you all so much. Thank you, Dr.
Thank
Mabuchi,
you.
for your honor. We're honored to have you here with us. and for sharing space with us. So, and everyone else, thank you so much for coming. To help us improve, thank you. Please take our short survey. This is a QR code, so just use your smartphones. And we hope you can join us next week, 5:30 on Thursday, March 13th, at the University Chapel, where Dr. Banu Subramaniam will lead a lecture on colonial botany. So exciting week next week as well. And again, thank you so much for today, for your insight. Very compelling presentation. I'm sure we all learned something new. Thank you.